Okay, hello and welcome to my channel. Today we're gonna continue the step potential and we will take a look at the case when your energy is equal to your V naught. So that means that your energy would sit here. Okay, so when energy is equal to V naught, that means, okay, I should write down the thing. Your E is h bar square k square over 2m. K is 2m h bar square E. And k tilde is 2m h bar square E minus V naught. And since E is equal to V naught, that would means that your k tilde is equal to 0. Therefore, your A now would equal to B, and by conservation, C would now equal to 2A. So how would that make your wave function look like? So quick reminder, your wave function is AE to the IKX plus BE to the minus IKX when x is less than 0, and when x is greater than 0, it would equal to CE to the IK tilde x. Right. So, sorry. Okay, so with A equal to B and C equal to 2A, that would mean that now your psi of x up here, you sub it in, you remember EI alpha plus E minus I alpha would give you 2 cosine alpha, right? So this would be 2A, because A and B is also A, 2A cosine kx when x is less than 0. Next is on C. K tilde here is already 0, so we're only left with C, which is 2A. So that means when your wave function got sent in, it would be a function of cosine with the magnitude here would be 2A. So it would go like that, that. And eventually here it would turn into the line 2A when at x equals 0. Alright, so now we're going to take a look at the probability current of the system right here. So, which part is not important? Okay, no, everything is important. Okay, so your probability current, quick reminder, it is J, which is equal to h bar over m, the imaginary part of your psi, imaginary part of the complex conjugate of psi times the derivative of psi. Now we assign the current on the left would equal to current A plus current B. And the current on the right would be the current C. Alright, so when we have this, we calculate. We calculate starting from x less than 0. Calculate the left. Okay, so first we're gonna calculate this guy, which is star times the derivative. This guy here is, remember we're taking the left, so this is the A star E minus IKX plus B star E IKX times the derivative So IKA e to the IKX minus B e to minus IKX. Right, now let's do the distribution. This guy and this guy cancel. So that would leave us with IK, the absolute value of A. Since, well, if you have this times this, that would be the absolute value. Okay, next term is this and that. That would yield you minus A star B E minus 2IKX. Next term, okay, I should write this a little bit more neat so I have more space. Okay, minus 2IKX. Next is plus IK AB star e to the 2IKX. Last term is minus, so I forgot that. So that means, yeah, no, this term is an IK. This term is that, and that cancels out. So that will be the absolute value of B square. All right, so you have this. You can do the grouping now. It would be IK. Put these two together. Okay, next is this guy right here. Minus IK out. Just write it short. It would be this. Okay. And you don't really have to care about this term since the exponential part doesn't terminate. Therefore, that when you have this guy here, it would be complex. So only this guy is all real. So you can say that erase this part. Okay, so now you can say that the imaginary part of this chunk is that, since only this is pure imaginary, because there is no I inside and there's an I outside. So that would equal to K absolute value of A squared minus absolute value of B squared. Okay, you put that thing into your current. That would give you, was that J left? That would give you H bar K over 2 over M. K over M A minus B squared. There we go. That would be your J left. Now, your J right, you do the exact same thing. And what you get is H bar K tilde M times the absolute value of C squared. All right. And these two, by the law of conservation, would equal to each other. So J left is equal to J right. And these would equal to a constant, right, by current conservation. Okay, next we're gonna be finding our coefficients. Okay, so get a place. This part right here. Okay, so what I was saying that we're gonna find our coefficients. Right, so the reflection, first let's take a look at reflection. I will write it as R would equal to JB over JA. That would equal to B squared over absolute A squared, right? Next is our transmission coefficient. That would be JC over JA. And first, you would think that this guy is simply just absolute C squared over absolute A squared. But you have to remember that, well, these two have a different K. So these two are kind of different, so you have to time it with the ratio of K tilde over K. So that is your transmission coefficient. Now, one more thing is also from current conservation, meaning that your JA minus JB, since, well, your wave hitting here would be bouncing back, that would have to equal to JC. And from this, you get that when you plus R plus T, sum of these would have to equal to 1, and that makes complete sense. Since, well, your whole thing, when you sum it up, it has to be 100%, so meaning 1. And that would be the end for today. Goodbye.